By the end of this video, you will understand what goes into a stormwater management report, mistakes to avoid when writing one, and what people are generally looking at when they are reading it. But before we dive into details, the first thing I want to say about a stormwater management report is that the main purpose of it is to show that your stormwater design will not affect the property that you're developing or neighboring properties after you develop your stormwater management system. More than 90% of the time, it's usually some sort of pre versus post development analysis, meaning you're comparing the pre-development to post-development discharge rates. But sometimes you'll have to compare volumes, and sometimes you might even have to do downstream analysis. Every stormwater management design is different. You can be designing wet detention ponds, dry detention, dry retention, underground storage. This design happens to be wet detention, but the most important thing that we're going to be diving into is just understanding what goes into a stormwater management report and how you can write better ones. But I'm ready to dive into it, so let's get to it. All right, here we have the cover page, really straightforward. You always want a title. Usually there's a whole bunch of stuff on here with who you're developing it for, the professional engineer's name who's going to sign it, but I'm going to skip the cover page because I'm sure y'all could handle a cover. So the table of contents for this one, we have our introduction, we got some pre-development analysis, some pre-development ICPR stormwater model, post-development analysis, post-development stormwater model, and then storm sewer calculations. Now, it's always really important to have a clear table of contents, and the reason why this is important is because other reviewers are reading this report. So when you're submitting this to a local agency, let's say a county or a water management district, you want to make this as easy as possible for them. And they might actually even look down here and see that there's 101 pages. That's a lot of pages to sift through, which leads me into the first thing about this stormwater management report is you need to be as clear and concise as possible in your narratives, your exhibits, and any sort of tables that you put in here. If I were to have any critiques of this one, I probably would actually put some page numbers. You can easily incorporate that with Bluebeam and even Word doc. But let's dive into the introduction and see what kind of important information is in here. And I promise you guys, I don't want to just like read it word for word, but what I do want to walk through is some of the critical information that goes into this and give you my perspective as a professional civil engineer who's been putting these together for a little over 6 years. Now, it goes without saying, you have to give some sort of intro or purpose, so you have to describe what you are developing. You're taking some sort of existing condition site and you're going to be developing something along it. So this happens to be a proposed development of single family homes located in Pasco County, Florida. It's always really good to help the reviewer understand where this is in space. So put an address if you have it, put intersections of major roadways, and put some sort of reference to a permit if you happen to be modifying some sort of existing permit or existing stormwater management system. Now, what I'll say here with the intro of the stormwater management report is that it's so important to tell the story between existing and proposed conditions. I think the bad stormwater reports that I read, they just don't go into enough detail on what you are doing. Honestly, even this one, the existing conditions, is really just talking about soils, whereas I really would have liked to see more information about the existing topography, the elevation, and maybe have some sort of table showing different basin breakdowns. In my past, it's been very helpful for reviewers to see a pre versus post summary just right here in the intro. And kind of to fast forward, I don't want to, but I've already sifted through all this, and one of the summary tables is actually almost dead last. So think about a reviewer, coming in here really just trying to understand your design high water levels, which is your stage within the pond. We're making it really hard for them because they have to read through the whole 101 page report to find this. Last but not least, it's very important to incorporate floodplain. So you can go to the FEMA firm met maps. I have other videos about this. You want to pull the flood zones, the firm map number, and the effective date, and clearly state what the 100-year base flood elevation is. And make sure you help the reviewer understand if you're providing any sort of mitigation. Now, at least where I'm from in Florida, there are two ways to provide floodplain mitigation. You can either, one, model out of it, meaning you're building a stormwater model around your site, and you're making sure that none of the neighboring properties are rising in any of the stages for any storm event that you run. The second way to mitigate for floodplain is that you can create what's called floodplain compensation ponds, which is really just some holes in the ground, and you get compensation for any sort of storage that you create between the existing grade all the way down to seasonal high water. So if you have a really low seasonal high water, you can create a lot of floodplain compensation. Even though I said floodplains last but not least, you really do want to address your different assumptions. So stating what type of method you're using. Is it SCS? Is it rational? Explain what you're trying to do. Are you trying to model between pre versus post discharge rates? Are you doing a downstream analysis? There's different ways to go about this. In this case, it looks like post-development peak discharge rates for the 25-year, 24-hour have been attenuated to less than or equal to the pre-development, which is so typical, guys. It's so typical to be pre versus post. You might hear that term a lot. All right, let's go to some of our maps. It's always important to put a project location map. It's really one of the first things that you should do. Now, what I would love to see with this is probably some road names, but I think this gets the point across that there's some greenery here, there's some wetland, there's some trees on site. Also, what's really popular is to show this UCGS quadrangle map. You can get these online. It helps show the different topography. Then next is the USDA soil data. You can get this from NRCS soil map. I've made, I think, 2 or 3 videos now on how to obtain these. This helps you understand what the hydrologic soil group will be, whether it's group A, B, C, D, and that affects your CN calculations. And then we have our FEMA map showing the zone AE and the X. And what we haven't gotten into yet are the basin and node maps, but those are going to come a little bit later. I'm going to put a caveat here that this stormwater management report is using a previously permitted pond and basin calculations, meaning there was already a permit on top of this area. So the engineer in this case had to understand that data, use the data, build a truncated model, and showcase that they are not causing any sort of impacts to the property or to neighboring properties. So some information was pulled, and I don't know if you guys have ever seen this type of page before, but this happens to be from a program called Stormwater. It's previously known as ICPR. And all of what we're showing here are some basin areas. So it's showing the name of the basin, it's showing the acreages, the curve numbers, and the time of concentration. Now, some of you may have never even heard of Stormwater or ICPR, so maybe you're more familiar with HydroCAD, SSA, HydroFlow. All of these programs are doing very similar things. You're assigning it basin areas, curve numbers, maybe some storage. You're pressing a button and it's helping you understand the pre-development or post-development runoff rates, the volumes, and the staging of the storage units. Now we're gonna get into our pre-developed drainage basin map. And I can't stress enough, guys, how important it is to clearly convey this type of information. I've seen some really bad basin exhibits in the past, and this happens to be a really, really clear one. I like the color coding. It probably would have been cooler if there was a colorful legend, but I think this is definitely clear and concise. So basically what this is showing is all of the different basins that are associated to this project. So all of these numbers here are the specific basins. This table is showing the basin area. Now, one thing that you need to do when you're QAQCing these reports is just make sure every time these basin areas update, sometimes it's an iterative process where you're still kind of manipulating things and understanding and you get more information back. Just make sure that your pre-development basin areas are matching whatever the heck is in your report. It's the first thing that a reviewer does. They're going to look, they're probably going to print this out, and then they're immediately going to go to your model input and start checking the boxes to make sure everything's aligning. Now we're going to look at what is called a nodal map. And a nodal map is showing the node reach of different storage units. So all these dots represent nodes, and these nodes are reaching to other nodes, meaning all of these storage units are connected via links somehow, whether it's a channel, a pipe, a weir. I know I'm missing a few on a drop structure. You have all these green nodes, which represent stage area nodes, which is an actual node with a specific amount of volume. But then you have some of these red nodes, which are time stage. Time stage nodes are usually your boundary nodes, and those boundary nodes are modeled as time stage increments, meaning the designer is assigning stage elevations at specific times to these nodes. And a lot of times those are developed by historical hydrographs. So for instance, if I were to take this node 9102, this is an outfall to some sort of boundary here. It could be a river, it could be a wetland, or it could just be where the designer happened to just want to cut off the model. So the designer ultimately got this information from a watershed model that was built, or maybe they perhaps even assigned it a basin area, understood the storage volume, hit run on a model to understand the hydrograph of that node. I mean, there's many ways to do it. Long story short, what we're looking at is how all of these different ponds and wetlands, ditches, pipes, and everything are connected. All right, last but not least is the input of the pre-development model. And Basically what you're inputting here, whether it's in Stormwise or HydroCAD, is all of the different basin acreages, CNs, time of concentrations, and then any sort of stage area. So this is when you're inputting stage versus area. This is creating a volume, and when we press run on our model, a whole bunch of water is going to go to that storage unit, it's going to fill up and then drop back down because it's being released somehow. It's being released by an overland flow weir, a pipe, channel, you name it. In this case, just so you guys are learning a little bit more about this specific report, let's just go to 10043. So that happens to be that one node right here. So 10043. So this is a node and it also has a basin associated. And basically this node right here has an initial stage at 41.64. So that's where its starting point is. And this is typically driven by either a pop-off elevation of a wetland, the bottom end of a ditch, or the seasonal high water. It really depends. Let's go to the next page. Then we can actually see its stage storage. So here's its stage storage. It's anywhere between 41 all the way to 43.15. This is a lot of acres. This is a really huge node. So the storage is almost up to almost 14 acres of storage all the way up to elevation 43.15. So now since you get the gist of the different input, it's time to start looking at some of the results. So as you're developing your model, you're going to need to put the results in here. And a couple tips that I'll give is you really just have to understand what your design storms are. So if you're working in South Carolina, it might be different than Florida. And if you work in Florida, it might be different than California. For this jurisdiction, it appeared that the simulation of the 25-year 24-hour and the 100-year 24-hour were used. And I can see that on this table, this little table right here. Simulation 25 100. Looks like we have the node names, and it looks like the designer was interested in these particular nodes and where the max stage elevation of those nodes were. So that node that we were already looking at, that 10043, the 25-year is 42.10 and the 100-year is 42.869. So this is what the reviewer is going to be looking at when they're trying to understand your pre versus post. They're immediately going to go to here to check your staging, and then they are going to go over here and check the max inflow. There's a certain amount of water that is being drained to this node, and the designer has to make sure that when they develop their drainage system that they're not discharging any more than that, which leads us into the next section of this analysis. So the most typical thing that you can ever give are the stage storage and the CN calculations of your proposed system. Like I said, this happens to be wet detention design. The designer is going to be putting in the different stages, the areas, and what this will create is an accumulated storage here. And what I really like about this is that there are clear remarks of where the normal water elevation is, where the design highs are, and where the top of bank is. I actually really like this. Now there's a huge caveat on this one. So every single municipality is different. So in Florida, you used to have to do what's called stormwater treatment calculations, which is using presumptive criteria. It's usually saying that you're going to treat 1 inch across a basin area. But actually all these stormwater rules are changing in Florida and everyone's freaking out. Now it's going to be all about BMPs and nutrient loading. So just always consult your municipality, but you should have some sort of breakdown of calculations that you're supposed to abide by for your municipality. This just happens to be the ones for this one. Lastly, you have your CN calculations. It's really always important to understand the land use type in one learning experience, okay? Everyone makes mistakes, right? I think one of the biggest mistakes I have ever made is I was doing a master model. I was working on it for like a month, and I was using a very, very, very low CN value of like 60 for, a residential neighborhood, which really, it's up to you, but it doesn't really make sense because residential is going to have a little bit more impervious area. There's buildings, there's roads. So a learning lesson there is do not screw up your curve number calculations or else you're gonna have to redo all your work. So always state your assumptions, ask around, ask your PM, talk to other people about it, be 100% on these. We're actually getting really close to the finish line. So here's what the post-development basin map looks like. So this is basically an overlay, it looks like, of the post basins versus the existing basins. I don't know if you guys remembered, but these dash ones were the pre-development. And as you can see, there are 3 ponds that will discharge to 10043. And that's going to be one of the nodes that we're looking at. Because remember how we saw the ICPR results earlier where it had particular staging, and then it also had a certain amount of inflow. Well, we're going to be monitoring that as we look at the post-development discharge rates of each of these ponds. What I really like is that there's a clear breakdown of post-development areas. And like I said earlier, these better match your stormwater management input. It's one of the first things reviewers look at. And just for our QAQC, let's look at it. So pond C, 3.43 acres of basin area. So let's find pond C. Here's pond C, manual basin, 3.43. All right, so it matches. If you guys have never used ICPR before, it's a very good program. I think it's a little bit more detailed than HydroCAD. It takes a little bit longer to learn and set up. However, it's very detailed, and I think it's good for large watersheds. Now, one thing I shouldn't skip over here is let me go to some of these inputs. So you might be wondering, like, where's all the different input for the ponds? So the ponds have really important input for the weir structures. So typically with wet detention ponds, there's some sort of weir that's going to control the pond. In this case, it happens to be a drop structure, and the drop structure is shown right here as drop structure link pond A. It'll show you the upstream pipe invert, downstream pipe invert. Let me go to the next page, and it should show you the different weir components. So basically what it's showing you right here is that it has 1, 2, 3 weirs. So the first weir being set at invert of 43, depth of 0.45, and a width of 0.85. That's one of the first weirs on the box. So it looks like this is actually going to be a compound weir, because I'm going to that weir 2, and I'm seeing that invert / control elevation is 43.45, which is set exactly above the max depth of the first one. So it looks like a compound rectangular weir. Now, the final weir is weir 3, which is horizontal, which is usually modeled as the grate. Now, one thing about this is that you don't always have to model the horizontal weir, especially if you know that the design high water doesn't get up to this elevation. Because sometimes what people do, and it's actually being captured right here, is the max depth was set at 999 for this weir, which just means that it's going straight to infinity, which just means the water's just gonna rise and fall. And basically whatever design high water you come up with in your pond, that's where you can set that horizontal grate. Sometimes it's set at the 100 year, sometimes the 25, sometimes it's set up a couple inches above the 100 year. It really depends on your municipality and what you're trying to do. All right, we're getting to the tail end of the stormwater report, and here's one of the most important things that I'm going to be looking at. So let's actually write this down, and this will be kind of like our final QAQC. And I'm sure there's a summary point, here. But, if I were to look at this and compare what was going on with that node, what I'm seeing right here is that node 10043, I'm going to write this down. It's now getting an inflow of 91.95 CFS during the 25 year. And if you remember, we might have to go back here. Originally in the pre-development, if I go right here, it was 101.45 CFS. So we've reduced the discharge rate. Now let's check the 25-year staging. So 44.33 in the 25-year. So now it is looking like 43.38. And to back check with some of these things, you can always double check pond A, B, and C, like whatever ponds are draining to that particular node. You can go over here to the outfall and add those up. You can also go to what's called the link max report in ICPR, or in HydroCAD, there's just going to be a report that tells you exactly how much is discharging. And here's what I really, really like, which concludes the report, is the complete breakdown of pre versus post inflow rate comparison. This is exactly what a reviewer is looking at. And then also the pond staging summary, because a lot of times there are different criteria with freeboard. So in this case, there was a requirement to have at least half a foot of freeboard between the design high 25 and the top of bank. Last but not least, what some people do is they'll throw in some storm sewer calculations. This happens to be what is called storm tabulations. Typically, there's some sort of exhibit associated showing all of the different sub-basin breakdowns, but I didn't find it in the report. All right, I know that was a lot, and maybe some of you actually stuck around, maybe some of you are asleep, but just to kind of summarize this, putting together a stormwater management report is like writing a story. Tell that story of how you're transforming that property into your development. Then you need to clearly explain how you plan to not cause any sort of disturbances to the property or nearby properties through erosion control measures, weir controls. Try not to make your stormwater reports way too long, but also don't gatekeep any secrets in a report. Make it clear, concise, use summary tables, put some page numbers, make your exhibits clear, and tell a good story. That's all I have for today, guys. I hope this has helped. If you're an EI or you're just starting out doing drainage design, comment below. I want to know what you're working on and what have been some of your biggest learning lessons. But that's all I have for today. I will see you in the next video. Peace out.